Welcome back to Kufi Sains. Today, we're diving into one of the most mind-bending concepts in quantum mechanics, Heisenberg's uncertainty principle. Get ready to question everything you thought you knew about the nature of reality. In the strange world of quantum mechanics, the rules of classical physics don't always apply. Particles like electrons behave in ways that can seem totally bizarre from our everyday perspective. And that's where Heisenberg's uncertainty principle comes into play. Werner Heisenberg was a German physicist and one of the key pioneers of quantum mechanics. In 1927, he formulated the uncertainty principle, which has since become a cornerstone of quantum theory. So, what exactly does the uncertainty principle state? In simple terms, it says that the more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. This isn't just a limitation of our measuring instruments, it's a fundamental property of the quantum world. Mathematically, Heisenberg's uncertainty principle is expressed as delta x times delta p is greater than or equal to h bar divided by 2, where delta x is the uncertainty in position. Delta p is the uncertainty in momentum, and h bar is the reduced Planck's constant. This inequality tells us that there's a limit to how accurately we can know both of these properties at the same time. Imagine an electron as a wave spread out over a region of space. The wave represents the probability of finding the electron at different positions. If we try to pinpoint the electron's position by making the wave more localized, the wave's momentum, represented by its wavelength, becomes more uncertain. Conversely, if we know the momentum precisely, the wave spreads out and the position becomes less certain. The uncertainty principle has profound implications for our understanding of the universe. For one, it challenges the idea of determinism, the notion that if we know all the initial conditions of a system, we can predict its future behavior. In the quantum realm, even with all the information, there's still an inherent uncertainty. This principle also explains phenomena like quantum tunneling, where particles pass through barriers they seemingly shouldn't be able to cross. But the uncertainty principle isn't just a theoretical curiosity. It has real-world applications. For instance, it limits the precision of certain types of measurements, like those made by electron microscopes. It's also crucial in the design of technologies that rely on quantum mechanics, like lasers and quantum computers. Before we wrap up, let's clear up a few misconceptions. First, the uncertainty principle doesn't mean that everything is uncertain or random. It's about the limits of precision in measurement. Second, it's not just about our lack of knowledge. This uncertainty is an intrinsic feature of the quantum world itself. Heisenberg's uncertainty principle teaches us that at the most fundamental level, the universe is a place of probabilities and uncertainties, not certainties. It's a mind-bending idea that continues to challenge our understanding of reality. Thanks for joining us on this quantum journey. If you found this video enlightening, make sure to like, share, and subscribe to BioDiscovery. Stay tuned for more deep dives into the mysteries of science.